Torpisc Presentation. This is a brief presentation of my invention, which is called Torpisc. Torpisc stands for the only real privacy in secure communication. What makes Torpisc unique is that there is no tool in the market that performs the same type of functionality as this tool can do for you. In this presentation, I'm going to give you a general overview of the basic functionality of Torpisc. If you find this tool to be of practical use to you and wish to get into what it can do for you, please watch my other presentations and then download the shareware release of Torpisc from my website. The shareware release comes with both introduction and tutorial sections that allow you to fully understand how to use this application. Torpisc is a revolutionary privacy tool for text messaging that is immune against both keyloggers and emissions. It is a tool that allows you to design, test, and use variants to the Solitaire encryption algorithm. Solitaire is a symmetric encryption algorithm that was developed by Bruce Schneier. What makes Solitaire unique is that it can be done by hand using a deck of cards as well as with this software application. If you are not already familiar with Solitaire, please follow the link in the introduction section of the shareware release of this application to read the tutorial that was written by Bruce Schneier himself. From this step onward, I am going to quickly take you through the full cycle of design, test, and use of your Solitaire variants. The first step is to design a Solitaire variant and start test simulations. So choose the corresponding settings and parameters that go with your new design. What you would want to do is to start with a Solitaire variant of your choice over here, and also make sure you take advantage of the cylinder mode to the right. The cylinder mode is intended to make the execution of steps asynchronous and to make sure that you don't end up having the exact same steps executed every single time. So this would randomize the key generation if it's used correctly. The print ink parameter determines the number of batches to run before actually spitting out the output. So if you're doing an exhaustive test, you need to increase this value. And then we have the substate num print, total state num print, and state block linked variables or parameters that are used for state analysis and are covered in the tutorial section of Torpisc. Before setting any of these values, you need to choose the number of cards that you want to choose, and then these values, the default values for these parameters, would show up over here. And then what I usually do is click on add here for the scenario checker and just set this to 3. Usually the first time you don't need to do any state analysis, so you can uncheck this. And then after you're done using n-gram testing, you can go ahead and retry, but this time with state analysis on. Once you start a simulation, the record numbers with their corresponding key combination and state combination values will be printed onto the screen every time updated results are ready. The frequency of graph sketch updates is a function of the print ink value, as I have previously mentioned. So if you're doing an exhaustive test, you need to make sure that the print ink value is high. And you should also keep in mind that the auto-analysis feature of Torpisc is one of the useful features of Torpisc that can save you time and energy, and tells you what the result of the bounce test is for anagram, diagram, and trigram tests over here. To get accurate results, you should let your simulation run in calculation mode for at least 10 minutes before relying on this information. And then if you look at the bottom of the screen, the parameters that you chose before running this simulation are shown to you to make sure that you can keep track of which simulation is which if you're running 8 simulations simultaneously in batches. And on the right side you have the mode, whether it's the write mode or the calculation mode. It is highly recommended to put Torpisc in deep analysis mode for a while for any simulation before putting too much stock on the results. This can be done by unchecking the print results submenu item from the settings menu. After you do this, please note that the simulation mode indicator at the bottom right corner of the screen will tell you that now the simulation is in calculation mode all the time. Torpisc allows you to run a maximum of 1.8 times 10 to the 24 keys for simulation. So regardless of what kind of computer you use, even if it's a supercomputer, it can completely handle it. And it's not going to crash due to an overflow of any kind. Torpisc also offers the option of zooming into the graph if you need more detailed information about record number values for key combination and state combination values. Then you can match the record numbers of interest to those in the simulation results window to get more specific information on the key combination or state combination values that correspond with the record number. The simulation results window gives detailed information on everything that you need to know about the simulation of interest. The most important pieces of information are the results of the bounds test over here and the results for the n-gram tests, which are both sorted and curved. So the highest one always gives you 1. And then if you are using the scenario checker based on the percentage from one combination to another, if there ends up being a gap that is higher than what you showed in terms of percentage, it would put a breakpoint in between them over here. This slide shows the results when the get state info is on, so you can see the state sequence results. And for each of them, you can see the state sequence followed by the number of hits for it. So you have commas here for the state sequence, and then double colon and followed by the number of hits when the key combination is whatever is shown at the beginning of the same line. And then you have the probability of this hit relative to other state combination hits that correspond to the key combination at the beginning of the line curved to 1 after this value. So you would have that over here. And as you can see, these state sequences are sorted for each record from left to right based on the substate non-print value that you have. So if substate non-print is 5, then you would have 1, 2, 3, and basically up to 5 sorted state sequences. The last number over here is the same value as the one before, except that it is multiplied by the probability of this particular state combination for all key combinations. The tutorial section of Torpisc goes into great detail on how to interpret the state sequence results. The Get the Keys window shows you how you can deterministically test your Solitaire variant designs. If you already have encountered a glitch in the random simulation, then you can use the cards snapshot from the simulation results window to set up the same deck position for the same Solitaire variant in this window, and then walk through the process of key generation to figure out what is causing the glitch. You can also run a depth search test on your design and compare nodes with your Solitaire results to rule out weaknesses in your design. For this step, what you would need to do is to enter a large text into the input text box and then set up the initial state of the deck. Then once you are ready to encode your messages, just click on encode to get the results down here, and then paste the results into a file. Select the file from the encrypt benchmarks submenu item to get the results for the entropy, chi-square, arithmetic mean, Monte Carlo, and serial correlation coefficient tests on the generated file to rule out glitches in your design. What this does is that it attacks your design from a totally different angle to rule out glitches. And then you can compare nodes with the results that you would get with Solitaire to weigh the strength of your design. Now you are ready to use your Solitaire variant design for text messaging because all of the testing is done and the results could look good. So from this point on, what you need to make sure you do is to use stealth mode for the arrangement of the cards in the deck, plus using the keypad for typing your messages. So make sure you cover your input text box with the keypad and then shuffle, and then when you click on cards in the deck, when you click on alphabet letters, you should also do mark clicks as well. Visit www.torpisc.com to download the shareware release of this application. It is freely available for download. You should also keep in mind that it's good practice to design several good quality Solitaire variants and then switch between them instead of using the same variant that you designed all of the time. Designing Solitaire variants is not a necessity to use Torpisc effectively, but it adds an extra dimension to privacy. So if you do not choose to go through all of the test steps that I outlined, but still wish to design good quality Solitaire variants, then you should rely mostly on the auto-analysis feature of Torpisc when you are running tests. Skipping state analysis altogether by unchecking the Get State Info option in step 2 is generally not recommended because basic state analysis helps detect biases that require much higher level n-gram tests to detect. So you should definitely do that, at least for trigram tests. So also keep in mind that state analysis is useful for design improvement clues so that you can get to your ideal design with a minimal number of revisions. At this point, I'm going to end this presentation. Please make sure you watch my other demos. I have Torpisc Design Demo, Torpisc Testing Demo, and Torpisc Usage Demo that you should definitely watch. Thank you for watching this presentation.